Hello everyone, in this video I'm going to discuss the example for function and graph and also the limit and continuity. Sketch the graph for the function fx where we have fx which is equals to the square root of, so we have 3x minus the 1, 3x plus with the 1. Then state the interval where the f is continuous. So kindly refers to the situation. First we are going to find the domain. So based on the situation where we have 3x minus the 1, 3x plus with the 1 greater and equals to 0 because of the square root. Next, here we have the simplest form. So kindly determine the sign. We have the positive. Continue. We have x greater equals to 1 over 3. X greater equals to negative 1 over 3. Kindly illustrate the situation in a real number line. So where we have negative 1 over 3 and 1 over 3. Then circle towards the right, then circle towards the right. So here we have the negative, negative and negative. So positive, negative and positive. So select the sign, we have the positive. So here will be the domain. So the domain for the f would be negative infinity until negative 1 over 3. Union, start from 1 over 3 until infinity. So that is the domain for the situation. Next, find the xy intercept. So for the x-intercept when y is equals to 0. So kindly substitute the situation where we have 0 equals to square root. We have 3x minus 1, 3x plus with the 1. So we square both sides. Then we will have 3x minus 1, 3x plus with the 1. So x is equals to 1 over 3, x is equals to negative 1 over 3. So that is the xy intercept where we have 1 over 3, 0. Negative 1 over 3, 0. Continue. We have the y-intercept when x is equals to 0. So kindly substitute. So we have y is equals to square root 9 multiplied with the 0 minus the 1. So y is equals to square root of negative 1. So does not exist. So there is no y-intercept. Continue. Next is to find the vertical asymptote. So limit when x approaching where we have the situation negative 1 over 3 from the left. Limit when x approaching negative 1 over 3 from the right. Continue. Limit when x approaching 1 over 3 from the left. Limit when x approaching 1 over 3 from the right. So kindly substitute the situation where we have the square root bracket 3x minus 1, 3x plus with the 1. Square root, we have 3x plus with the 1, 3x minus the 1. So by referring to the real number line, where we have negative 1 over 3 and 1 over 3. So negative 1 over 3 where we have negative 0.3 with the repetition 3. So from here we have negative 0.3334. As for the right, we can see that based on the domain does not exist. Next, we have 1 over 3. As for the left, does not exist. Then we have 0.3334. So kindly substitute the situation. So for this case, if we substitute the value negative 0.3334 into this part, then we will have the value approaching to 0. So same goes to this part. So we will have 0. So as x approaching negative 1 over 3 from the left for the function fx, the value of y will be approaching 0. As for the right hand side, we have does not exist. So you may refer to the number line. Continue. If we substitute in this part, for sure we will have does not exist. Again, for this part, if we substitute, we will have the value approaching 0. Same goes to this part. So the value of x. So the limit when x approaching 1 over 3 from the right, we will have the value of y approaching 0. Continue. We have the horizontal asymptote. Limit when x approaching negative infinity, square root, we have 9x squared minus the 1. If we substitute the negative infinity, and we will have the positive infinity. Limit when x approaching positive infinity for the function 9x squared minus the 1. And the value of y will be approaching positive infinity. So kindly refers to the graph. So we have the y-axis and the x-axis. So first refers to the domain. We have negative 1 over 3. Then here we have 1 over 3. Then based on the x-intercept, we have 1 over 3, 0, negative 1 over 3, 0. So here will be the location. Negative 1 over 3, 0. Then here we have 1 over 3, 0. Next, we have the y-intercept does not exist. Vertical asymptote as x approaching negative 1 over 3 from the left. We have the value approaching 0. So where we have here. Continue, does not exist, then does not exist, then limit when x approaching 1 over 3 from the right, approaching 0. Limit when x approaching negative infinity, we have the positive infinity. So meaning that the graph will be something like this. Same goes to the right hand side, we'll have the graph something like this. So where we have the fx, which is equals to square root of 9x squared minus the 1. So state the interval where the f is continuous. So based on the domain, so the interval would be negative infinity until negative 1 over 3, union from the 1 over 3 until infinity. So continuous for the fx. Next, function g is defined as the follow situation. So given that g is continuous for all the value of x, find the value of the constant m. So based on the situation here, they mention continuous, so meaning that limit exists. So limit when x approaching 1 over 3 from the left for the function gx is the same for the limit when x approaching 1 over 3 from the right for the function gx. So let's focus on the situation. Limit when x approaching 1 over 3 from the left. So refers to the situation here, we have the number line. So they mention 1 over 3 until 1 over 3. So x is a subset in negative 1 over 3 until 1 over 3. So meaning that here we have m squared plus with the 3. Then not included means that we have the square root 9x squared minus the 1, square root 9x squared minus the 1. So kindly refers to this part, 1 over 3 from the left. So we will have mx squared plus with the 3 equals to limit when x approaching 1 over 3 from the right for the function square root 9x squared minus the 1. Kindly substitute the situation. So here we'll have m over the 9 plus with the 3 equals to, kindly substitute 1 over 3, so we will have the square root 9 bracket, we have 1 over 9 minus the 1. So we will have 0 on the right hand side. So kindly continue. So m over 9 plus with the 3. So m over 9, which is equals to negative 3. So m is equals to negative 27. Next, function h is defined as the situation. So where we have the hx, which is equals to 3x minus 1 over the square root of, if we factorize the situation, we have 3x minus 1, 3x plus with the 1. Next is to find the domain. So as we all know, for this part, the domain will be all real number. So we have to focus the denominator. We have the square root, then we have 3x minus 1, 3x plus 1 greater than 0. Because for the denominator, we cannot equate to 0. Next, we have the simplest form. So here we have the positive sign. So x greater than 1 over 3. X greater than negative 1 over 3. Kindly illustrate the situation in the real number line. So we have negative 1 over 3, 1 over 3. So empty circle towards the right, empty circle towards the right. So here we'll have the negative, 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 positive, negative, positive. So we're interested for the positive side. So the domain would be negative infinity until negative 1 over 3 union 1 over 3 until infinity, where the 1 over 3 and the negative 1 over 3 is not included. Next, second step, xy intercept. So for the x-intercept, when y is equals to 0. So if we substitute the situation, so we will have 3x minus 1 is equals to 0. So x is equals to 1 over 3. So kindly refers to the domain. For the x is equals to 1 over 3 is not included. So from here we can see that there is a point of intersection 0, 1 over 3. So 1 over 3 is not included. Then for the y-intercept, x is equals to 0. So by referring to the domain, we notice that x cannot be equals to 0 because it's not defined. So y-intercept does not exist. Next, refers to the situation. We have to find the vertical asymptote. So limit when x approaching negative 1 over 3 from the left. Limit when x approaching negative 1 over 3 from the right. Limit when x approaching 1 over 3 from the left. Limit when x approaching 1 over 3 from the right. So kindly substitute the function given. So here we have 3x minus 1 over the square root of 3x minus the 1, 3x plus with the 1. Repeat the situation for all the cases. Kindly refers to the real number line. We have negative 1 over 3 and also the 1 over 3. For the left hand side, for this case, we have negative 0.3333. So for the left hand side, we have negative 0.3335. As for the right hand side, does not exist based on the domain. Then focus on the 1 over 3 from the left. Does not exist. From the right, we have 0.3335. So kindly substitute the situation. So if we substitute the situation for this part, then we will have a negative value. So for this part, we have a negative value. Then here we will have a negative value as well. So from this case, we have the negative infinity. As x approaching negative 1 over 3 from the right, does not exist. Same goes to this part, does not exist. Next, focus on 0.3335. So if we substitute by using the calculator, notice that we were approaching 0. So from here, we can say that the vertical asymptote is x is equals to negative 1 over 3. And for 1 over 3, it is not vertical asymptote because it doesn't show increasing or decreasing. It is approaching the 0. Next is to find the horizontal asymptote. Horizontal asymptote. Limit when x approaching negative infinity. Limit when x approaching positive infinity. So we have the situation 3x minus 1 over, we have the square root, 9x squared minus the 1. So by referring to the definition, we have the square root of x squared, or we can say the modulus of x, where we have the definition x negative x. So x greater equals to 0, x less than 0. So we have the situation 0, negative x and x. So if we substitute for this part, we will have negative infinity over the infinity, where we have the IDF. So the strategy would be dividing the numerator and also the denominator by referring to the highest power of x for the denominator. So for this case, limit when x approaching negative infinity, factor out the x. So we will have 3 minus 1 over the x. Over, we have the square root of x squared multiplied with the square root of 9 minus 1 over x squared. So by referring to the definition, here we have the square root of x squared, which is equals to the modulus of x, and we have the definition. So for this case, we have negative infinity, means that towards the left. So we have to make use of the negative x. So kindly simplify the situation. Limit when x approaching negative infinity, we have x multiplied with 3 minus 1 over x. Over, we have the negative x multiplied with the square root of 9 minus 1 over x squared. Simplify. So limit when x approaching negative infinity, we have 3 minus 1 over x over, we have the negative square root of 9 minus 1 over x squared. So kindly substitute the situation. Then we will have the situation in here we have 3, and then here we have negative square root of 9. So we will have negative 1. As the x approaching negative infinity, the value of y is approaching negative 1. Next, we have the limit when x approaching positive infinity. For this case, we have x multiplied with 3 minus 1 over x. Over, we have the square root of x squared multiplied with the 9 minus 1 over x squared. So for this case, we have positive infinity, so meaning that greater equals to 0, so we have the x. So kindly substitute the situation. Limit when x approaching positive infinity, we have the x multiplied with 3 minus 1 over x squared. Over, we have the x multiplied with the 9 minus 1 over x squared. So limit when x approaching positive infinity, so 3 minus 1 over x squared over the square root of 9 minus 1 over x squared. So the value of y will be approaching 1. Horizontal, asymptote, y is equals to negative 1, y is equals to 1. So let's sketch the graph. Kindly refers to the domain. Where we have the domain, negative 1 over 3 is not included, and also the 1 over 3. So let's say here we have negative 1 over 3, and here we have 1 over 3. Continue. Refers to the xy intercept. As we all know, y-intercept does not exist. We have the x-intercept 1 over 3, 0, but is not included. So we can say that not included. Continue. Refers to the vertical asymptote as x approaching negative 1 over 3 from the left. So we have the asymptote x is equals to negative 1 over 3. So the situation will be negative infinity. So meaning that the graph is going down or decreasing. Then as approaching from the right does not exist. Then continue. As x approaching 1 over 3 from the left does not exist. As x approaching 1 over 3 from the right. So we have approaching 0. Next we have the vertical asymptote x is equals to negative 1 over 3. Continue. Refers to the horizontal asymptote. We have approaching y is equals to negative 1. So here we have the negative 1. So this one is decreasing just now. Another one is y is equals to 1. So the situation will be around here and also around here. So the graph would be something like this. So that is the situation for the hx, where we have 3x minus the 1 over the square root of 9x squared minus the 1.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.